Okay, so now let's put to use what we've learned about how to find the area between two curves. So suppose we have the functions y equals x and y equals x squared. Here in this problem we have no limits of integration. We are not being told what we are to find the area from, like x equals a to x equals b. We are not being given that in this problem. So we have to find then the limits of integration by setting the two functions equal to each other, x squared equals x, and solving for x. So take the x to the other side, can't combine them, factor, and x would be equal to 0, and x would be equal to 1. Now you've got to get a sketch. So we're going to bring back our basic graphing techniques. This is very important. You're going to take this x, when x is 0, and put it into either one of these functions. So 0 into here is 0 squared is 0. And I'm going to take this 1, put it into either one, because it'll be the same for both. And I'm going to get back 1. Okay. So these are the points where the two graphs will intersect each other. Now what you have to pick is you have to pick an x in between these. So between 0 and 1, a nice x to pick maybe is a half. You can pick anything you want. If you put a half into here, you're going to get 1/2. So this will be 1/2. So add a half, y is a half. Shape it. This is a straight line. Y equals mx plus b. So connect it like 1 through those 3 points. Now when I pick a half for this function, 1/2 squared is a quarter. Well, that's down here. That's below. So shape it like an x squared function. Remember your functions. X squareds, negative x squareds, x cubes, straight lines, constants, square roots, absolute values, all your basic shapes. Your exponentials like e, ln, It's very important to know which function's on top, which one's on the bottom. And how we know that is, if I pick a half for this function, well, into here, a half is bigger than the y down here because when 1/2 is squared, I get a quarter. So how does 1/2 compare to 1/4? 1/2 is bigger, which means in this interval from 0 to 1, this function x is on top of this function. Now I'll draw my rectangle. Make sure you draw the rectangle to indicate the indicated area. So now my area will be the definite integral from 0 to 1. Since I drew the rectangle vertically, it's going to be a top minus the bottom. And I want you to do this. The top function, bullet that on the top of the rectangle minus the bottom. That's the top minus the bottom. The function that's on top is x, and the function that's on the bottom is x squared, dx. And now what I will do is I'll take the antiderivative without 83, x squared over 2 minus x cubed over 3 from 0 to 1. I still have great satisfaction at always doing the calculation of the area by hand. You can, of course, check it using the TI-83 with the Math 9 feature from 0 to 1 of x minus x squared. Put in the 1 and you'll get 1/2 minus 1/3. 3 minus the 2 over the 6. Our area is 1/6. And remember, you should never get any negative areas. Okay, next one. Where y equals x squared and y equals root x. Again, I have no limits of integration here, so I'm going to set them equal to each other. And to undo the square root, I will square both sides. And then now I will set it equal to 0. Factor out an x. And x would be equal to 0, or x would be equal to 1. So now again, we're going to go from 0 to 1. When x is 0, I'm going to put it back into here. And neither one I'll get 0. And I'll put 1 in. And of course I'll get 1 here. Pick something in between. Well, since I have to take a square root, I'm not going to pick a half. I'll pick a quarter. So if I pick a quarter, the square root of a quarter is a half. So this is a quarter, say, and I'll be up a half. shape it. Once you have the third point, you need 3 points. Once you have the third point, shape it as you're supposed to know its shape. Square root functions are shaped like this, so shape it. Now if I pick a quarter, pick that same x value for this function. Put it in here. You won't get the same y value. So 1/4 squared is 1/16. That's right down here. That's really small. This y value is less than this y value. 1/16 is less than 1/4, which means this function will be below that function from 0 to 1. And that's the shape of x squared, a parabola concave up. Draw the rectangle to indicate the shaded area, and really bullet that top minus the bottom. So the area will be equal to the definite integral from 0 to 1. The function on top is root x minus the function on the bottom, which is x squared, dx. Take the antiderivative, that'd be x to the 3/2 times 2/3 minus x cubed over 3 from 0 to 1. Put in the 1, and I'm going to get 2/3 minus 1/3, which ends up being 1/3. I didn't bother with the 0 because I know putting 0 into that would be minus 0, but that will not always be the case. Alright, once again, area cannot be negative. Next, suppose we have y equals 1 minus x squared and y equals x minus 1. So I'm going to set them equal to each other. 1 minus x squared equals x minus 1. Negative x squared minus x plus 2. I'll leave that there, take it over to minus x plus 2. Divide out the negative, so I have x squared plus x minus 2 equals 0. Reverse FOIL that. X and x, 2 and 1, positive and negative. So x is 1, or x is what there? Negative 2. So I'm going to integrate now from negative 2 to 1. You need those y values. So I'm going to put negative 2 back into either one of these, and negative 2 squared is 4, 1 minus 4 is negative 3. So 1, 2, 3. And then I will put 1 in and get 0. So once again, you have to pick an x in between. These are the limits of integration. These are the x's where the two functions will intersect each other, where their graphs will cross over each other. You need an x in between. You need that third point. So pick 0. That's a nice number between negative 2 and 1. So if I pick 0, I'll get negative 1 for this one. Connect it as you're supposed to know its shape, which is a straight line. Be careful here. Like that right here. This should have been down. When I had x being 0, I get that. Negative 1, but I went down a little too, really off scale here. Okay, so there's that. It's a straight line. If I pick 0 for this, I get 1. Now, this is a parabola, negative x squared. It's a parabola concave down. So shape it. There's that third point. Here are the two endpoints. That's where they intersect each other. That third point will tell you now how you're supposed to shape it using your prior knowledge of your basic graphs. You should know that negative x squared is a parabola concave down. I'll draw a rectangle in to indicate the area I'm about to find. So the area would be equal to the definite integral from negative 2 to 1. Since I drew it vertically, it's going to be a top minus the bottom. So the function on top would be 1 minus x squared minus the function on the bottom, which is x minus 1 dx. Distribute the minus sign through and clean that up to be negative x squared minus x plus 2. And then now take its antiderivative. So that's going to be equal to negative x cubed over 3 minus x squared over 2 plus 2x from negative 2 to 1. Let's practice this. Putting in a 1, I get negative 1/3 minus 1/2 plus 2 minus, putting in a negative 2. Get good with this arithmetic. Negative 2 cubed is negative 8 times a negative is a positive 8/3. Negative 2 squared is 4 over 2. You can just leave it as 4 over 2 because you're going to combine it with the other one. Minus 4. Run the negative sign through. I'm running out of some room here, but I'll have negative 1/3 minus 1/2 plus 2 minus 8/3 plus 4/2 plus 4. And I get negative 1/3 and negative 8/3 is negative 9/3 or 3. Here I get plus 6. And then here I get 3/2. Negative 1/2 plus 4/2 is 3/2. So it's going to be 3 plus 3/2. And 3 times 2 is 6 plus 3 is 9. So I get 9/2 or 4.5. And once again, you can take your 83 and you can go math 9. And you're going to go 1 minus x squared minus x plus 1, comma x, comma, negative 2, comma 1, close it, enter, and you get 4.5 or 9/2. Throughout the rest of the videos, I may not have a chance to do this kind of arithmetic, but definitely get this set up for you. And next, last, what if we have this? X equals y squared and x equals y plus 2. If they're solved for x and you have the y's being squared or the y's being cubed, listen carefully. Solve the functions for x. Solve them for x. And these will end up being functions of y. So now I'm going to set these equal to each other, set it to 0, and factor. So then I'll get y equals 2 and y equals negative 1. Now how do we set this up? Well, everything's just in terms of y now instead of x. So this is not good. So now when y is negative 1, put this into either one. Negative 1 squared is 1. So I'm going to get here 1, negative 1. When y is 2, I get 4. So over 1, 2, 3, 4, up 2. There's that one. Those are the endpoints. Those are where the functions or the graphs will intersect each other. But now I need to figure out a point in between. Well, before, when these were x's, I picked an x in between them. Now I'm going to pick a y in between them. Well, what's a nice y between negative 1 and 2? 0. 0 is a real nice one. So when y is 0, I get x is 0. There it is. After you've picked that third point, shape it. Shape this one. I picked y is 0 for it. X was 0. Shape it. Y squared is a parabola swung sideways like that to the right. Now you can pick the same y, and I recommend that you do, for the other functions. 0 plus 2 is 2, so it's 2 for x. This is a line. Whether it's solved for x or y, it's a line. And there's that. And because my graph, if you will, is going sideways, you could think of it as, and we solve these for y, we're going to, the first time, draw the rectangle sideways. There it is. So when it's sideways, everything is in terms of y. Everything is in terms of y. The limits and the integrand. So the limits will go from negative 1 to 2. And this time, it's going to be a right minus the left. When this rectangle is drawn sideways, it is right minus left. So it's going to be here the right function, which is y plus 2 minus the function on the left, which is y squared dy. Remember, the height now is your dy. It's the difference in the y's. Your width now is the difference in the x's, if you will, but these x's are functions of y's. Clean this up, and I get y plus 2 minus y squared. That antiderivative would be y squared over 2 plus 2y minus y cubed over 3 from negative 1 to 2. And I'm not going to do that arithmetic now. As you saw me before, you put in the 2. Well, I guess I will here. 2 squared is 4 over 2 is 2. So that's 4 over 2 plus 4 minus 8/3 minus, putting in the negative 1, I'm going to get 1/2 minus 2, negative 1 cubed is a negative, plus that is positive 1/3. Distribute that, I'll get minus 1/2 plus that and minus that. So then 4 halves minus 1 half is 3 halves. 4 plus 2 is 6, looking like the other answer it was. Negative 8 thirds, negative 1 third is negative 9 thirds, and minus 3. 6 minus 3 is 3. And then 3 plus the 3 halves, of course, is still going to be the 9 halves. And even though these are in terms of y, you could still enter that in the Math 9 feature just using x. And the 83 does not know that you're using a y function, a function of y. Okay? So that's the important thing, is when you draw the rectangle sideways, it's in terms of y, and it's a right minus the left. Just one thing I did not come up with yet was an example where they gave you the limits of integration. So just suppose, like for example here, let's see, we have y equals, let me just see if I can come up with a function like this. And suppose we have, let's see here, what can I do here? Y equals, say, yes, let's do this one, e to the x. And the other one is y equals 0, x equals 0, and x equals, say, 1. Okay, so here, you may not have an intersection. If you attempt to set these equal to 0, and then you ln both sides, you know that the ln of 0 is a d and e. So e to the x, if you pick x as 0, that's a recommendation. E to the 0 is 1. And e to the first is just, of course, e. So you know that the shape of e, from 0 to 1, is shaped like that. There it is. Y equals 0 is the x-axis. Y equals 0 is the x-axis. X equals 0 is a vertical line, and x equals 1 is a vertical line. So this time, what we have going on here is we do not have the graphs intersecting each other. But that's okay. We don't need them to intersect each other. We have our limits of integration being given to us from x equals 0 to x equals 1. So what I'm going to do is then draw, one rectangle to indicate that. You have to draw the rectangle. In all my problems, because especially when it comes to volumes, without that rectangle, you won't know which volume method to use without drawing the rectangle. And it also gives great meaning to why we're doing what we're doing. So again, this is e to the x, this is y equals 0, this is x equals 0, and this is x equals 1. We have no intersection here, but that's okay. So the area would be equal to the definite integral from 0 to 1 of the top minus the bottom. When that rectangle is vertical again, it's top minus bottom. So it's going to be e to the x minus 0, which is just 0 dx. And the antiderivative of e to the x is e to the x from 0 to 1. E, be careful here, don't be so quick to think that that's 0, because e to the 0, as you know, is 1. So the point in doing this problem is that when you see these, x equals a constant, and they are given like that, we have to take those into account, because the region is all of this. It's enclosed by all 4 equations. It's enclosed by all 4 equations, and they definitely have to be taken into account. It's just that now these will be your limits of integration where there was no intersection with the graphs. Okay?